Okay, so day two, we're looking at zeros and multiplicities. It says identify if the graph is a polynomial function. Um, if it is, state the zeros, the least degree of the polynomial can have, and then write its equation of least degree. Okay, so, and they do have the equation here, but we're going to look at, how we're going to do it. So first of all, is this a polynomial? Yes, it's a nice smooth curve, no holes, no asymptotes, no jumps in the graph. So yes, this is a polynomial. Polynomials are nice smooth curves with no breaks in them. Okay, if it is, state the zeros. Well, the zeros are, we can see -2. We can't see the other one. They'd have to tell you that. I'm going to tell you it's -1/4. That they would normally give you. Anything I would be asking you, I would give you that. Because the point of this is to not use our calculator. And x is 3 is the other one. Least degree. Well, since this crosses, we learned yesterday that if it crosses the x-axis, it has an odd multiplicity. So the least odd number, the smallest odd number we could have is 1. So the least amount of times this zero can occur is once. Same thing with this, same thing with this. So that would mean we would have a degree of 3. 1, 2, 3. They each occur once. There's 3 zeros. Leading coefficient, well, we said if it starts up and ends down, ending down means it has a negative leading coefficient. So if I were now going to write the polynomial function, f of x, I know the leading coefficient is negative. I don't know the value of the leading coefficient, so I'm just going to call it a right now. And then I know since x minus 2 is a 0, x plus 2 is a factor. Right now, we're going to write this as x plus 1/4. And then this is x minus 3. Now, we don't really write with fractions in there. So what I'm going to do is I'm going to multiply here by 4 to get this to be 4x plus 1. Okay, so double check. Does 4x plus 1, if you set it equal to 0, does that give you -1/4? Yes, it does. Y-intercept, I'm going to tell you the y-intercept here is 6. Now, technically, we have the equation there, so we could see it's 6, but remember the point of this is really not to have that equation. So they'd have to tell you the y-intercept. If they tell you the y-intercept is 6, that means f of x is 6 when x is 0, right? That's what a y-intercept is. It's the value when x is 0. Okay. This would be 2 times 1 times -3. That would be 6 equals 6a, which means a is 1. So if I were writing the equations, if I go back right here, f of x equals -a is 1. I don't need to write 1, right? 1 times anything is just that thing. So that's the equation. Now, I'm going to usually just let you stop right here. You would see, though, if you FOILed all of this through, you would get this equation over here. But again, normally we don't have the equation. We're finding the equation. So like in the next one, I don't have the equation. I see it crosses at -4, crosses at -2, kisses at 3. So is it a polynomial? Yes. Nice smooth curve, no breaks in the graph. Zeros are -4, -2, and 3, which has to have at least a multiplicity of 2. So why does it have to have at least a multiplicity of 2? Well, because the graph kisses the axis at 3. So it has to have an even multiplicity. What's the smallest even number? 2. These occur once because it's the smallest odd number and it's crossing. Degree of this, well, if this one occurs twice, once, this is 2, 3, 4. So degree 4, it has 4 zeros because really it has 3 zeros, but this 0 occurs twice. They could get a degree 4. Leading coefficient is positive because the ends are up. All right, so leading coefficient is positive. We don't know what that leading coefficient is. We'll get to that in a minute. This is x plus 4, x plus 2, x minus 3 has a multiplicity of 2. So that means that factor of x minus 3 occurs twice, which is why we get x equals 3 twice. Okay, so now we're going to use the y-intercept. Y-intercept is 3. I should say y-intercept is 3 here. Y-intercept is the y value when x is 0. That's 4, 2, -3 squared is 9. Divide by 72. We're getting a would be 1/24. So, writing this equation, it's f of x equals the a. So I'm filling back in here. Now, example 3 here, I could just say not a polynomial because there is a jump in the graph. Or I could talk about the hole in the graph, jump in the graph, hole in the graph. Those would all make this not a polynomial function. Right? We saw our rational functions would have holes in them. Right? That was one place where we saw holes in the graph. Okay. Here, kissing the axis. So is this a polynomial? Yes. What are the zeros? Well, x equals -6 is a 0, occurs at least twice because it kisses the axis. So it has a multiplicity of at least 2. X equals 2 is 0. Again, occurs at least twice. Degree is 4. Leading coefficient is negative because the ends are down. Both ends down. Leading coefficient is negative. Degree 4, this occurs twice, 2 and 2, 4. Okay. So we say f of x equals negative, I don't know what a is, x plus 6 occurs twice. That's how we get x equals -6 twice. And x minus 2 occurs twice. To find a, what's the y-intercept here? Looks like a y-intercept of -5. So that means f of x is -5 when x is 0. 6 squared is 36. 2 squared is 4. Yeah, that's negative 144a. So a is 5 over 144, right? It's negative 5 over negative 144, but then a negative divided by a negative is a positive. So what is my equation? Well, it's f of x equals negative. So we're plugging into this. We're just filling the a in. 5 over 144, x plus 6 squared, x minus 2 squared. Okay. All right, last question. And this goes back to what we did on day 1. Sketch the graph of, and they give you this equation. So what I would want to think about, first and foremost, what is the degree of this polynomial? Well, if I expanded this out, that would be an x squared times an x times an x, which would be an x to the 4th, would be my leading term. So this is the leading term. So that's a degree 4. Leading coefficient is positive because it's a positive x to the 4th. This is positive, this is positive, this is positive. So positive times positive gives me positive. Okay, so then I would identify what are the zeros, what's the multiplicity of each zero, and does it kiss or cross the axis? So this has a 0 of 2 and exponents 2, so it has a multiplicity of 2. So write this, I kind of wrote over that, but this x minus 2 factor occurs twice. So this 0 of 2, right, if you set that equal to 0 and solve, it's 2. That is going to occur twice because this factor occurs twice. And then you got the x plus 2 and the x plus 4. So setting that equal to 0, that's negative 2. Only has an exponent of 1, so it just occurs once. So this means kisses, even multiplicity. This crosses because it's an odd multiplicity. And then we have negative 4, which occurs once. So that is an odd multiplicity. So again, crosses. The other thing we usually get is a y-intercept. Y-intercept is the y value when x is 0. So I'm plugging 0 into that. It's my f of x function. So this is 4 times 2 times 4, which is 32. Okay, so I have to say, okay, there's a 0 at 2, 0 at negative 2, 0 at negative 4. It's a degree 4 with a positive leading coefficient. That means I know the ends are up. Both ends are up. And then I know it has, I have to cross the y-axis at 32. Now, at 2, which is here, I kiss the axis. These two, I cross the axis. So, could look something like this. End has to be up. So I'm up, I'm coming down, I cross. Have to go through my y-intercept. Now, I'm making it a maximum. I don't necessarily know it's a maximum, but this is just a sketch, so it doesn't matter. And then it has to kiss the axis here, and the other end has to be up. Degree 4 with a positive leading coefficient, the ends are up. And I'm going to practice limit of f of x as x approaches negative infinity. So as I move this way on the curve, as x goes to negative infinity, where are my y's going? Infinity. And the limit of f of x as x approaches positive infinity. As I move to the right on the curve, my y's are shooting to infinity. Okay, that is it for day 2.